video about doing the 1.2 activity, transforming. So the only thing about the remote days is if you're not watching the videos, you're actually missing out on some really cool graphing calculator activities that you're going to be able to use on homework, quizzing, and testing. Let's look at the last activity, 1.2. Let's look at the 1.2 activity. We already did problems 2, 3. Now we're going to look at 4. All right. So on your graphing calculator, and we were transforming, you have to go to apps, which is in purple right here. It says apps. Hopefully your calculator has this on it. Go to the purple button apps and scroll all the way to the bottom. It's the very last one. It says transform. I go to apps. And because I know it's all the way to the bottom, I'm actually going to arrow up because it'll give me the very last thing that's there. There it is. Transform is the last thing on here. So I hit enter. Use it. We go to y equals. Clear out anything you have in there. And I'm going to start with number 3 just to kind of talk about it. We want to punch in y1, which is the first one. We're using letters. That means you got to use alpha because all of the letters, the capital letters, are green, so we got to use alpha. So I'm going to do alpha math, which gives me the A letter, A, parentheses, x minus alpha for B, close the parenthesis, and then square the parenthesis. I need to center my screen. My screen is way off. So I'm going to go to Zoom, and I am going to hit number 6 to put me back in a 10 by 10 grid. Zoom, number 6, and then I'm back to that 10 by 10 grid. This is a degree 2 because it's raised. It says x squared. Okay, it says x being raised to the second power. So this is our x squared function. We're looking at, like, I'm going to take my A here, my A, and I can punch in any number that I want to. I would like to go back to A is 1. And I'm just going to put 1, enter. All right, there's A is 1. And I want B to be 0, so I'm going to go down arrow. We're at the origin when A is 1 and B is 0. Okay, that's just y equals x squared. That's the parent function. Number 2, if I look at number 3 over here, I'm going to skip number 2 because we've already done that. You did another calculator exercise that was about just A. This is about A and B. It says make A 1, and again, use the arrows to enter values for B. Identify the pattern that's going on. If I let B equal 1, if I let B equal, and I could just push 5, enter. If I let B equal 5, what's happening to the parabola? If I let B equal -5, what's happening to the parabola? What's the pattern that you're seeing going on here? So I need you to make sure you've answered questions A. What happens when B is positive? What happens when B is negative? I give myself notes. Okay, I said, okay, when B was 3, what did it do? When B was -3, what did it do? What would the equations look like? And then you want to answer letter B. Describe the changes as B increases. What happens when B decreases? When B increases, what happened to the function? When B was 3, when B was 5, what happened? So what's really important to notice here is the equations. If I look when B was 3 and I substituted in 3, it says x minus 3. Students will look at that and they'll go to -3. But that's not true. It's the opposite of that. You go to 3. What happens when I substitute in a negative -3? Then I have x minus -3, x minus -3, which is really x plus 3. That's important that you have that and that you understand that. When it says x minus 3, I'm going to +3. When it says x plus 3, I'm going to -3. These are your notes. This is what you're using for quizzing and testing and homework. So make sure you are clear on which case is which. When it says x minus 3 squared, I'm going to +3. When it says x plus 3 squared, I'm going to -3. That's because the formula has a negative in it, x minus. That minus sign is going to change the sign of any number after it. That was the first one. Now, what happens when we go back into y equals and we add plus c? Go back to y equals, and scroll over with your arrow key, and let's put plus c. How is c going to affect the graph? How is c? So I want to reset my other ones. I want everything reset. A is 1.
So squared.
B is going to be, I'm going to let b equal 1 as well. And c is 1. Now I'm going to mess around with the c value, arrow down and here on the c. I like to punch in some kind of big number so I can see the thing jump. If I just punch in a smaller number, I don't always see that what it's doing. So pick a number for c, do a positive number, a negative number, and then describe what's happening to c here. What happens as you press to increase c? What happens when you're decreasing it? Write down in your notes how c, so I'm going to go, okay. We have y equals a x minus b squared plus c. What is happening to c on the graph? Just up? Very good. So which variable, let's see, it moves it up and down. What did b do? B did what?
Left and right.
So b was about left and right.
C's up and down. A.
B is about left and right. C is about up and down. And A is about what? Now, look on the board when we talk about A. It's about the width of the parabola. Okay, so A is about the width, B is about left or right, and C is about up or down. I have a question for you. When you say left or right for B, which variable is that representing in our function? It's moving left and right. X. So it's about the x-axis, right? Moving left and right is about the x, isn't it? What is the C representing when it's going up and down?
Y.
It's representing the y, okay? That's very important to know that B is representing what's happening on the x-axis going left and right, and C is about the y-axis moving up and down. All right. Change B and C so the vertex of the parabola is at 4, -3. So change B and C to be 4 and -3. We need to write this equation once you get it done. I need to write an equation for this vertex. Y equals, A was 1. Is it going to be x plus 4 or x minus 4? X minus 4 means I went to the right squared. Is it going to be plus 3 or minus 3? Minus 3, I went down. So the only time you're thinking opposite is when it's in parentheses with a sign. 4, -3 is the two numbers we just substituted in. This is really key right here. Y equals x minus h squared plus k. You're going to see this for every function. It's always going to be x minus. It's always going to be an x minus h and a plus k. It may be a degree 3. It may be a. So I can't stress to you enough how much you're going to keep seeing this formula through the whole entire school year now that we've made it here. Oops. Y equals a times x minus h squared plus k. This is a parabola. Okay, I can do the same thing for an absolute value, x minus h plus k, absolute value. I can do this for a square root. That would be y equals a square root of x minus h plus k. So this formula is used for every single function. Okay, this is a basic formula for all functions and where they're centered at. Why is this called vertex form? Why is x minus h squared plus k vertex form? It gives the vertex, h. So I could say that hk, my b and my c, hk is the vertex. And the vertex is always known as a max or min, depending on what a is. So when you hear vertex, we're talking about max and mins, the highest and lowest point that it's going. And then last thing, describe what A, H, and K are all doing to the graph. First thing I'm going to do is shut my transformer off, though. You go to apps and uninstall. So I go back to apps because we're not doing any more transforming. Quit out of this page. Apps. Go all the way to the bottom for transform. Enter and uninstall. I want to talk about one quick thing before we go to 1.2 about homework and what it means when it says label the vertex and the axis of symmetry. All right, so I'm going to do problem 19. All right, so when I do problem 19, I know that I want to find the vertex. So if I looked at standard form in my foldable, it would say I'm using x equals negative b over 2a. So x equals negative b is 12, over 2 times negative 3, which is negative 6. And I get that x equals 2. What is that? What's x equals 2? What is it? What did I just find? The axis of symmetry. That means at 2, I would draw a dotted line. It says to label. How do I label that? I don't go AOS and point to it. What kind of line is that? What kind of line is it?
Vertical.
It's a vertical line. Vertical lines have equations, and the equation is x equals 2. That's how you label it. Don't write AOS and then draw an arrow to it. You're labeling your graph. And it's okay if you didn't do this exactly on your first assignment, but from now on, for any assignment, when it says to label it, you're actually using the math to label the graph of what it is. Then the next thing that I would do is I would take this. I know that my parabola is going to land on the AOS. Is it facing upwards or downwards? How'd you know it was facing downwards? The negative out front. So I know it's facing downwards. So that vertex is probably going to be up here somewheres. How do I find that? I just substitute in the x value. If I want to know what y equals when x is 2, I just substitute it in. So that would be negative 3 times 2 squared plus 12 times 2 plus 7. This is big right here, what I'm going to say right now. It'd be even bigger if the negative was on the inside here. Students are multiplying and then raising it to the exponent. Is that true?
No.
What rule tells me that I would not multiply before exponents? PEMDAS. I have to have an order. Order is all around us. We live in a universe of order. My body is governed by order. I need order. So you start with exponents first. That's negative 3 times what's 2 squared?
4.
That is one of the biggest mistakes that I see besides labeling, is not doing exponents before you multiply. All right, so I do my exponents, and then I keep going, 24 and 7. Negative 3 times 4 is negative 12, plus 24 plus 7. So that's 12 plus 7 is 19. That means my vertex is at 2 for x, and I found out that y was 19. So I go to 219. How do I label that? The vertex is a point in space. I label it like this, 219. That's fully labeled and not getting any points off. I have a vertical line, and I have a coordinate for that point right there. Then I finish it, and I like the y-intercept because who doesn't like working with zeros unless, of course, it's in your checking account. So f of 0 is going to be what? Do I actually have to do it out, or can I just say what it is? What's f of 0? It's going to be 7 because that's going to be 0 times a number, 0 times a number. That leaves 7. So that means 0, 7 is the y-intercept. 3, 6, 9, about here. And then I can use symmetry to finish the parabola. I am 2 units away on this side. I'm going to be 2 units away on this side. And then I graph it. All right, that's it. Label it, your vertical, your asymptote, and your vertex. Boom. Done. Now we're moving into our 1.2 notes. We're talking about the vertex and intercept form. Civil engineering. The Tacoma Narrows Bridge in Washington has 2 towers that each rise 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by this function. Each cable, where x and y are measured in feet. What is the distance d between the 2 towers? We're looking for d. We have this suspension bridge. We have towers of 307 feet. Lots of stuff going on here. Does anybody have any idea how they want to approach this problem? Anybody in virtual land as well? Please feel free to speak up. Where would I want to start on this? I have this equation, so that really draws my eyes. We know A. Do we know anything else? Do we know H or K? B or C? What's HK represent? The vertex. So if I knew the vertex, that could help me. Go ahead and find out what the vertex is. What's the vertex? So the vertex, there's the vertex form. HK is the vertex. So that means that, is it positive 1400 or negative 1400? Positive 1400. And K is 27. There's my vertex. How does that help me find the distance? What's the distance? What other characteristics do we know about parabolas? We have the vertex. What other characteristic is always part of a parabola? The axis of symmetry. So I know the axis of symmetry is right here. Do we know how much anything is right now at all about the distance? How much to go to here? How much? That's not x. It's 1400 to go to here. So how much to go for the entire distance? So this is 1400. And we know it has symmetry. So this is 1400. Therefore, the distance D is 2 times 1400, or 1400 and 1400, which is 2800. So we didn't have to do anything. We just need to know how to use the numbers that are in the equation. And we also have intercept form. Example 4. Football. The path of a place-kicked football can be modeled by the function. You see the function here, where x is the horizontal distance in yards and y is the corresponding height in yards. How far is the football kicked? What is the football's maximum height? What do we have here? We have this function y equals negative 0.026x times x minus 46. I could actually solve these two right here. And this one right here, what would I get? X minus 46 equals 0, so x equals 46. X is the horizontal distance. So here's x. That means that this is 46. How far is the football kicked? 46 yards. So it was kicked, it goes up, it lands. What is the football's maximum height? Where am I looking for the maximum height here? Where would I look for maximum height? The vertex. Good wording. The vertex. So maximum height is about the vertex. Do I know anything on this vertex at all based on what we've already done? Do I know anything at all? I know that it was kicked 46 yards. Do I know anything about that vertex? Do I have any numbers at all? What do you got? How'd you know it was 23? So again, she's using the symmetry. Using that symmetry, well, if all of this is 46, that would mean that it'd be 23 and 23. So how do I get to that vertex? It's 23. X is 23. So I do know that x is 23 based on the fact that parabolas have symmetry and it's cut in half. How do I figure out the height? Does that give me the height? No, the y value is about the height. So how do I find y? F of 23, substituting in my x to my formula, which would be negative 0.026 times that x, 23. Then I have another parenthesis of 23 minus 46, substituting in the x value of 23. Use your calculators, get an answer, and I got 13.75. So f of 23 equals 13.75. So that would go here for the vertex. Then I just have to answer the question. What was the football's maximum height? 13.75 yards. Example 5 is, what form do you think that this is in right now? Yes, it's in intercept form. And I need to change it into standard form. All right, so we are in intercept form. We need to multiply these together. So I'm going to keep my -2, and I'm going to multiply these two together. It's like doing the distributive property 4 times. I'm going to start with the x, and with the x, I'm going to multiply twice. I'm going to do x times x in the other parenthesis, and then x times -8. I'm distributing the x onto x minus 8. So x times x is x squared. You add exponents. This is x to the 1 times x to the 1. We haven't got to exponents yet. You add your exponents. That's why it's x squared. Okay? You add exponents. So x times x was x squared, and then x times -8 is -8x. Okay, I'm all done with the x, the first one. I just multiplied twice with it, and now I'm moving on to the 5. Now I need to distribute the 5 onto x minus 8. So it's going to be 5 times x, and then 5 times -8. So like I said, it's distributive property 4 times, or some people call it FOIL first. So we have 5 times x is 5x, a positive 5x. 5 times -8 is -40. Before I multiply by that -2, I could simplify. You have 2 terms on the inside here that are like terms. -8x and positive 5x is going to be -3x. And now I'm ready to distribute a property one more time. How many times am I going to multiply the -2? 3 times. There's 3 terms on the inside. So -2 times x squared is -2x squared. -2 times -3x is positive 6x. -2 times -40 is positive 80. And that would be y equals ax squared plus bx plus c in standard form. Example 6. Which form is it starting in? All I'm trying to do is put this in standard form. I need to multiply. I need to think about how I can start putting it in standard form. Any ideas on how you'd like to start? What do you got, Mary? Okay, multiply the what? So do you mean do the exponents? So we're going to start with, order of operations says you do start with exponents. So I'm right here. There's nothing on the inside I can do. I can't do x minus 1, nothing to it. But I can show what this means to be squared. What does it mean to be x minus 1 squared? What's that mean? What's it look like? Very good. If 5 squared means 5 times 5, then a parentheses being squared means a parenthesis times a parenthesis, whatever's on the inside. So I would say 4, and then x minus 1 times x minus 1 plus 9. I would expand it out, just like you do on exponents sometimes when you were in elementary school or junior high. Sometimes you expanded them out. All right, so I'm still going to start here. So that's 4 times, we're using the FOIL method, x times x first. X times x is x squared. And then x times -1 is -x. And then I move to the -1 to multiply. And I usually go from under, so I don't have all these arrows on top. -1 times x is -x. And then -1 times -1 is positive 1. And I'm writing down everything that I have here so I don't leave anything behind. Simplify what's on the inside of the parentheses. How much is -x, -x? -2x. -1 is -2. I have plus 1. Do I add 1 and 9 together now? Why not, Diaz? What do I need to do right now then? Very good. Distributive property multiplying. So PEMDAS says parentheses, exponents, multiply. There's nothing more in here I can simplify, so now it's multiplying with the distributive property, 4 times x squared, 4 times negative 2x, 4 times 1. And I can drop my parentheses now that I've distributed the 4 onto everything on the inside. Now I have it in standard form. All right, I would like to fill out the foldables today. So we're going to start with characteristics, something that we already know about. When a is greater than 0, what's the parabola? Opens. Which way does it open? If a is greater than 0, does it open upwards or downwards? It opens upward. And then I'm just going to show a little sketch of it. Is this considered a maximum or minimum? It's the lowest it can go. So that would be a minimum. When a is less than 0, the parabola opens up. Evan, this one's for you. Is this a minimum or maximum? It's the highest it can go, so it's a maximum. All right, so now we're under vertex form, and we want to know what A, H, and K are. Here's our formula right here. A is 3. H is 2. And K is 4. What's the vertex? So we know the vertex is HK, and that is 2, 4. So I'm going to go to 2, 4, put a vertex. And if I know the vertex, I know, the AOS. They go hand in hand. If I know the AOS, I can get to the vertex. If I know the vertex, I know that AOS. I put the dotted line there, and I label it as such, x equals 2. This is my vertex at 2, 4, and label it. The AOS is a vertical line, x equals 2. And then I need to find the y-intercept. All I need is one more point, and I could sketch it. Is it facing upwards or downwards? It's facing upwards, and I feel like this is one of the graphs I wanted to fix. Yep, it was. I keep forgetting to do that every year. So right now, what I'm going to do then is I'm going to change my graph to go by 4s. 4. All right, so 2, 4. I'm finally in the right place. All right, there's the vertex. How about the y-intercept? If I only had one more point, is this parabola facing upwards or downwards? I always give bonus points when students go like this. They're like, it's a degree 2. This is the way the degree 2 goes, and I know that it's this one. I actually give bonus points on testing because when we get into more functions, there's all different kinds of functions. So you're saying I know what the positive and negative one looks like, and I'm circling the one that I expect that it is. I actually give bonus points correctly, and I want to give you bonus points for that. How do I find the y-intercept? Is it going to be just 4? Are you willing to take that chance? So how do I find it then? F of 0. And I'm putting it in right to this. So that would be 3 times 0 minus 2 squared plus 4. So we have, again, we start with exponents first. Negative 2 squared is 4. No, what's negative 2 times negative 2? 3 times 4 plus 4. So it's 16. So when x was 0, we found the y-intercept was 16. So you can only use C when it's in standard form. If it's not in standard form, you need to substitute in 0 to find the y-intercept. 0, 16, and now I'm ready to graph because I am 1, 2 away on the left. That makes me 2 away on the right. I can see the U shape, and I graph it. Then we're going to answer the questions down here, just practicing. What is the vertex and the AOS? What would be some errors that you think students might make on this problem? Evan? So they might think that this was negative 3?
That's what I did.
Good. Okay, let's look at, we did standard form, intercept form. Intercept form. So we can see from the formula that's going to be down here, intercept form is A times x minus p x minus q. P and q. What are P and Q? If I look at the picture up top that's there, what does P and Q represent? They're x-intercept. This is intercept form. So we're not talking about y-intercepts here. We're talking about the x-intercepts. You can look at the picture right here and see that this would be x is P, 0. So I go over P units, that's an x-intercept, and I go over Q units, and that's an x-intercept. So we are looking for x-intercepts in intercept form. All right, here we go. So we have this graph, y equals, we have this function, f of x equals 2 times x plus 3 times x minus 1. Find all the x and y intercepts. So B, x-intercepts are what? What are the x-intercepts? Is it 3, negative 1? So if you look at the formula, look, it's got the minus signs in there. That's the opposite of what you're seeing. Okay, so it's not 3, it's negative 3. So negative 3, 0 is an intercept. What's the other intercept? 1, 0. So there's the x-intercepts. How do I find the y-intercept? How do I always, no matter what function it is, find the y-intercept? 0. X is 0. Whenever you're looking for a y, look at, here's my x-intercepts. What's 0? Y 0. That's how you always find intercepts. If I'm looking for the x-intercept, y is 0. If I'm looking for the y-intercept, that means that x is going to be 0 something. X is 0. So I'm looking for f of 0. I just substitute it in. 2 times 0 plus 3 times 0 minus 1. So f of 0 equals 2 times 3 times negative 1. So we do have this graph down here. I'm going to transpose some of this information, my intercepts. We have negative 3, 0, 1, 2, 3. When it says label, this is how you label it. I don't ask you to label all the time, but when it says label, that's what I'm labeling an intercept. That's what it looks like. And then at 1, 0, is this parabola facing upwards or downwards? It's facing upwards. So we're coming through here, we're facing upwards. And then my y-intercept is 0, negative 6. 1, 2, 3, 4, 5, 6. 0, negative 6. When I label it like that, I don't have to label the axes. Part C. I want to find the vertex in the AOS. Well, the AOS we're going to start with. The equation for the AOS, when you're in intercept form, is on the graph. It's on the vertical line. It's x equals p plus q divided by 2. We'll put x equals p plus q divided by 2. Add it up and divide by 2. That's how you find the middle point. So we have x equals negative 3 plus 1 divided by 2. Negative 2 divided by 2 is negative 1. So my AOS is at negative 1. All right, so there's my AOS, and I label it. X equals negative 1. And I just need my vertex. You substitute it in. The AOS is negative 1, so I would do f of negative 1. And looking at my original, we have 2 times negative 1 plus 3 and negative 1, negative 1. 2 times 2 times negative 2. So the vertex is at negative 1, negative 8. 7, 8. Do I have enough points to graph it? I do. I don't have to use symmetry and find another point on the other side. I mean, I could if I wanted to, but I don't need it because I've got these two up here. So it's coming down. Everything's labeled. Intercepts, y-intercept, my vertex, I need a label there. Negative 1, negative 8. All I can say is make sure you read the directions for exactly what labels they want.